Guys, any question on this problem? Second problem. And if not, I'll go ahead with the third problem. Okay. So okay. So let's go to third problem. Yeah, basically you are given a uniform random variable distributed from 0 to 1, and you are given a quadratic equation x square plus 4ux plus 1 equal to 0, which has two distinct real roots x1 and x2. This is important. It has two distinct real roots x1 and x2. So what is the answer? I mean, how do you proceed with this problem? Anyone? You're given a quadratic equation and you have want to have two distinct real roots. So what do we do for that? What is the condition for a quadratic equation to have two distinct real roots? Okay, uniformly distributed random variable is this thing, whose distribution is like this, the density function. You know Gaussian, right? It is another kind of random variable, uniform because you take equal intervals of anywhere between 0 to 1, you have same probability, right? So how do you approach this problem? Equal probability of choosing a number, right? If you sample numbers from that distribution, you will get all the numbers equally likely. Because it is continuous, you can only say the range of numbers. So what I mean is, if it is uniform from 0 to 1 and you divide it to 10 bins, 0 to 0.1 and 0.1 to 0.2 and so on, so probability that you find any number between 0 to 0.1 and say 0.2 0.3 will be same. So that's what the uniform means. Okay, so given that and you are given this equation x square plus 4ux plus 1 equal to 0, and you want to have two distinct roots, how do you, so what range of values of u satisfy that? Given that if you know the range, you can find the probability, right? So what is the condition to have two distinct real roots for a quadratic equation? Okay, so this is the question. U is a uniformly distributed random variable, which I explained, between 0 to 1. And you are given this equation x square plus 4ux plus 1 equal to 0. And you want to have two roots, different roots for this equation, right? What is the probability? Cool, right? Discriminant should be greater than 0. So that's what it is, right? Discriminant should be greater than 0. So this is, if you take this discriminant, that is square root of 16u square minus 4, that is nothing but 4u square minus 1. This to be positive, 4u square has to be greater than 1, right? And that's it. So you get for u to be greater than 1 by 2, right? Or u to be less than minus 1 by 2. U less than minus 1 by 2 you will never encounter because your support is between 0 to 1, right? What is the probability that u is greater than 1 by 2? That is 1 by 2, right? That's it. Now any questions on this? If not, we'll move to fourth question. Otherwise you can type a query. Okay, cool. So let's go to another question. So x is a random variable having this CDF, right? Probability x, you are given some CDF, right? F, capital F of h, as you can see, and right, so you want to know what is the probability of this set, right? So let's plan this thing. Okay, so if you draw the CDF, right, this part is I think 1 plus x by 9 or what it is. Yeah, 1 plus x by 9 is 1 plus x by 9. And this is I think 2 plus x square by 9. 2 plus x square by 9. So now you want the probability that x belongs to this subset, minus 1 to 0. 0 is closed. Yeah, 0 is closed. 0 is closed. Okay, so because these two are disjoint, right, you can sum up the probabilities that x belongs to this or x belongs to this. That's why you get a sum. Because you know the CDF, right, you can put this x belongs to minus 1 to 0 means, as you've seen earlier, minus 1 is less than x is less than 0. So that's like f of fx of 0 minus fx of minus 1. So at 0, you have two things. There is a 1 by 9 and there is 2 by 9. Because this is continuous from the right, if you are considering 0, okay, now if you are considering 0, it should be from the right side of the distribution, right? So I mean, when you come from the right to 0, what is the value that you see, right? Just to go above 0, we are close to 2 by 9, right? So that's why it is 2 by 9, not 1 by 9. Okay. So minus 1, it is 0, right? The same thing. And here is the tricky part, right? 1 to 2. Well, 1 to 2 is given as open interval, right? So ideally, I should write this as 2 minus. 2 minus from means that you are approaching 2 from the left, right? If I were given as a closed interval 2, I should approach from the right because it is right continuous. Right, so that's why fx of 2 minus minus fx of 1. Okay, fx of 2 minus is 6 by 9. Right, put 2 here, right, that is 6 by 9. And fx of 1, it is, I think, 3 by 9. Yeah. So overall the answer is 5 by 9. Any questions on this? You can see it for a while and let me know if you have any questions. Can you be more specific? Open and closed interval are pretty trivial, right? So basically here, so distribution functions are right continuous. Yeah, in this problem 0 is closed. That's it. Only at 0 you have this closed interval. Everywhere else you have opens. Okay, so you have to be careful while you are dealing with densities where there are discontinuities, right? So if you cannot take, basically here, right, at 0 you are taking it 2 by 9, but at 2 you are taking this to be 6 by 9, not this one, the one. The reason is this thing, right? In this interval you are not including 2 here, right? So it is like 2 minus, right? 2 minus represents any number smaller than 2. It approaches 2 but it never hits 2, right? So 1.9999999, whatever, how many nines you write, it can take but not 2. So that's what I meant by 2 minus here. And if it were closed, right, you should write here 1 instead of 6 by 9. You should write 1 if this were closed. Similarly, if this were open, you should write this as 1 by 9, okay, instead of 2 by 9. Is it clear now? Okay, so let's go to another problem. This is I think very simple. Okay, you are given a distribution function. This is piecewise linear. Not even, yeah, it should be piecewise linear. The convention arises from the definition of CDF. Correct. The convention, by convention you mean the why you are taking for 0, you are taking the 0 plus, right? When there is 0, you have to come from 0 plus. That is coming from the definition of CDF, because CDF is continuous from the right. Okay, so yeah, this is a simple problem. You are given x going from 0 to 10 and you are given distribution, okay, not the probability. Okay, so at 0.25 you have again at 1 it goes to 0. It's like a staircase, right? Now you want to find the probability of this conditional probability x less than or equal to 5 given x greater than 2. So this is very easy. I'll quickly go over this thing. Okay, so this is it, right? This is the question, and this is it. Just by definitions you have to write this. X greater than 2 is 1 minus probability x less than or equal to 2, and because x is greater than 2, less than or equal to 5, 2 cannot come here. That's why in the summation I'm writing 3 to 5 times this in summation you have probability. Okay, and what is pi? Because you are given CDF, pi is you can compute as the difference between that minus accumulated, what has been accumulated so far up to I minus 1. That gives you the probability of I. Okay, I think this should be simple. Ping me, let me know if you have any questions even on this. Okay, so we can go to question 6. Right, this is simple. You have given a sample space 1, 2, 3, and f is a sigma algebra on omega. You are defining a random variable x of w. W is element of omega as w plus 2, and you want this x of w to be a random variable. For that, which of this f is a valid sigma algebra? You have given 4 options, right? So this f is p of omega, right? Power set of omega is a valid sigma algebra, because none of these given f's, right, covers all the events such as x of omega less than or equal to x for all x belongs to real numbers. Okay, I think we have seen this in one of the previous assignments, right? A similar question. Any questions on this? I mean, so take this thing, right? So you have 1, 2, 3, and this is mapped to 3, 4, 5. Okay, so you want, what are the events basically in your sigma field? Whatever sigma field you define on omega fp, right? This set should be in f. Say let's put this as alpha, and alpha belongs to R for all real numbers. If I choose alpha to be say 3.5, what is the omega, right? What is this set? This set is 1. If I choose alpha to be 4.5, what is the omega, right? Omega is 1 and 2, right? If I put anything uh, greater than or equal to 5, your set is nothing but omega. Any sigma algebra should contain these sets, right? I mean, omega anyways trivially it should contain, and so this thing, right? So basically none of the sigma algebras given have these two sets, 1 and 1, 2, right? So yeah, so power set contains all the possible subsets, that's why it's the valid sigma. It's clear. We have worked out this problem. if you guys remember, I think in last or before that. In fact, we even went on to say the minimum number of sets that you need to add here to make it a valid sigma algebra. So it was not even power set, if I remember. So you can go back and check. Okay. So yeah, so this is some amplifier. Okay, input output characteristics are given like this. Y is square root of x is positive, y is minus square root of modulus of x when x is negative, right? What is the distribution of y when x has a standard normal and of 0 1? 0 mean unit variance. So how do you attempt this problem is I'll go through this quickly. Okay, so here is the transformation. Okay, y is positive square root of x, and when it is negative it is square root of minus x, right? And y goes from minus infinity to plus infinity. Okay, this is the transformation that is given. We want density of y. So first we find the distribution of y, then we can differentiate and get the density. Okay, so that is nothing but this is by definition of distribution, and here you substitute root x plus y is root x less than or equal to y. We only deal with the case when y is positive. Okay, so y positives will only come when x is positive. Okay, and this is nothing but x less than y square, and this is nothing but the, again this is coming from the definition of CDF. Okay, here it's a definition, here it's a definition of CDF. You just differentiate it, you get the density. First part is, I hope it's clear, right? Let's go to the next part. When y is less than 0, right? This comes only when x is negative, right? So y, this is again definition, right? This is what is given, right? And this is less than or equal to y. When you multiply with minus, your inequality is reverse, right? That's why this is greater than or equal to minus y, and this is mod x is greater than or equal to y square. Okay, when x is less than 0, mod x is minus x, right? Again, when you switch your negative sign there, it again goes to minus y square. This is nothing but fx of minus y square. This is again by definition. You differentiate it, you get it, this 2 times minus y, right? Fx of minus y square minus 2y. Here remember y is negative. Okay, that's why this is overall thing is positive, because it is standard normal, right? This is symmetric. Fx of minus y square is same as fx of y square. That's why the overall distribution is fx of y square times 2 times modulus of y. Got it? Any questions in this series of inequalities? You can look at this for maybe a minute or two. If you still have questions, I'll answer. Okay, so let's go to next problem. Um, yeah, omega is a collection of sets that is given them, and you are defining an event an, a sequence of events an as if it is odd, s1 as odd indices, if it is even indices. What is the probability of this event? Lim inf of an. Okay, so lim inf of a sequence of sets is defined like this. Basically, you have to take the intersections of say all the events first, right? Now you have to leave out one set, again take the intersection, again leave out two sets, again take the intersection, right? Because it is an intersection, the first set is the smallest set, right? And second set will be bigger than the first set, and so on. So these are the sequence of increasing sets, and you are taking the union of them. So that uh, final set is nothing but limit. Okay, so basically what we are given is s1 s3 when n is odd, s2 s4 when n is even. Now fix any k, right? Say k 100. Now if you take intersection of these sets a100, a1001, a1002, what you will end up getting is you are trying the intersections with the odd sets and even sets, right? Which is empty set, right? Because there is nothing common here. It's s2. Okay, so for any k you fix this is 5, and union of empty sets is still an empty set. So the probability of empty set is 0. That's why it is 0. Okay. Union of intersection of sets. That is the idea. I mean, in this problem, there is nothing. We just want to confuse you. That's it. So if I put instead of S2, here if I put S1, okay, what do you think this will turn out to be? Instead of S2 here, if I put S1, what do you think this, after doing this, all this operation, unions and intersection, what do you think you'll get? S1, okay, cool. So I hope you understood now, right? And the final answer is probability of S1 you have to give. So in this context, that is 1 by 6 if it were S1 instead of S2. Okay, so yeah, so this is a simple question. CDF of X is given like this, right? Some form. Okay. So what is the value of A for this to be valid CDF? Again, you have to use that crucial property, the right continuity of CDF. Okay. So let me show the answer. right? So from the, because it is right continuous, phi, if you are approaching say some, this is again some CDF, I don't know, whatever it is 1 greater than or equal to 5, you are given it as 1. Sorry, greater than 5, it is given as 1. So when you are coming from the right to 5, right, that is effects of 5 plus. 5 plus means what? It is greater than 5 but not equal to 5. No matter how small it is, small in the sense say 5.0001 is also 5 plus. So by definition of this CDF, right, this is 5, right? So fx of 5 plus is nothing but your 5 greater than 0, right? That is 1, right? This is given to be 1. That's why fx of 5 is 1. Right? The reason I have written fx of 5 is 1 is because of this. In your question, this is given to be 1, not this. Okay, so that's it. You substitute, you get a is equal to 7. Any questions on that? Okay, so your final question is very simple. This is a transformation that is given y is equal to sine x, and x has this density minus pi by 2 to pi plus pi by 2. Sorry for this typo. It is 1 over pi. And this is the CDF. This is density. CDF has this form 1 over pi times x plus pi over 2. Right? You want the density of y. Like fx, you want fy, small fy. And by definition, right, first principles, you go with f of y less than or equal to y. And right, so y is nothing but sine x, so that's why x less than or equal to sine inverse y. And you need to be very careful when you write this, right? So we have written here for sine x, that is minus 1 to 1, right? This is minus pi by 2. This is 1, this is minus 1, this is pi by 2, and that is minus pi by 2. Okay, so I am saying that y is, say this y is less than or equal to some alpha here, right? This y, this alpha corresponds to on x-axis sine inverse alpha, because y is sine alpha. Okay, I am now, this guy is less than alpha. If I say x is less than or equal to sine inverse alpha, this is not true if this function is not an increasing function. I hope you understand and appreciate that. Okay, so you cannot write if it is not a monotonical function, monotonically increasing function to be specific. Okay, so that's why you have done this, and this is nothing but by definition this is fx of sine inverse y, and you substitute this in this thing, you get 1 over pi sine inverse y plus pi by 2, and just differentiate this, you get that. That's it. And y belongs to minus 1 to plus 1 for all minus 1 to plus 1. Okay, so that's all I have for today. Reference book. Uh, you can see this Sheldon Ross probability models and Papaulis also. Let me write down. Okay, guys. So, um, if you have any other questions, any problems, right, you can type in. I can come back next week. Let me stop the recording.